Zoom, hit done, share the screen, start the broadcast, optimize for video. Give me just a moment, I'll be right back. All right. Sorry about that. Okay. So welcome, gentlemen. I hope everyone is doing well. No major announcements. I think we just finished exam 2 that was due, I think maybe a few minutes ago. I think that's right. So you can expect me to update grades within the week, right? So aside from that, we're just going to kind of continue with the next one. All right. Let's see. View single page. Okay. All right. So we've officially completed chapter 1, right? So we're moving into chapter 2. Again, our rhythm pretty much for the remainder of the semester is a section a week. You know how it goes. So anywho. So we're moving into chapter 2 with polynomials and rational functions. We're going to start with section 2.1, the quadratic functions, and we have a few objectives. One, graph a quadratic function in its standard form, graph any quadratic function, and then solve problems modeled by quadratic functions. So a quadratic function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, where a is not equal to 0, is called a quadratic function. Some things to note is that the highest power in any variable is a 2, right? We've explored this one already on some level, so you should know at least by now that this should be a U-shaped curve, right? And then this is this quadratic function in the form of f of x equals a times x minus h quantity squared plus k, where a is not equal to 0. We say that this is in standard form. The graph of f is going to be a parabola with the vertex h comma k. The parabola is symmetric with respect to the line x equals h. This is called the axis of the parabola. You may also hear me refer to it as the axis of symmetry. If our a is positive, which is our leading coefficient, then the parabola is going to open upward. If our a is negative, then the parabola is going to open downward. Okay, so my opinion is like when graphing quadratics, I feel like this is the easiest form for it, the best form for it to be in the graphic. Because it gives us the coordinates of the vertex. The vertex is essentially the turning point of the parabola, where it changes from either increasing to decreasing or vice versa. It's going to be our h comma k. If our leading coefficient is positive, the parabola is going to open upward. If our leading coefficient is negative, the parabola is going to open downward. Okay, and then we can use the axis of symmetry to generate several points. All right, so the axis of symmetry is going to be the x coordinate of the vertex. Whenever we get a point on the right-hand side of the axis of symmetry, we automatically get a point on the left. So you find a few points on one side. Again, each point is 2 for 1 with the exception of the vertex. So once you have the vertex, axis of symmetry, and a few additional points, that's more than enough to graph a parabola. Okay. So here we're asked to find the standard form of a quadratic function given this vertex, and it passes through this point. So I think on the previous slide, again, every time we use a formula, write it down. So, and if you have a formula sheet, it is a good idea to update your formula sheet with the standard form of a quadratic function, which is this guy. Okay, and we have several formulas that you're going to want to be able to reference at a moment's notice. So hopefully you have a notebook where you're keeping a log of the work that you're doing, kind of making your own manuscript, right? That's the idea. Okay. And again, the power comes in like creating the manuscript, not in having a manuscript. Having it, then that's like having the internet and you have to search, and that's you're not really learning anything, you're just learning how to search. But if you create it, then you actually learn it. You tend to learn it more because you take all that time to build it, then it becomes like second nature or whatever. So the standard form of a quadratic, a times x minus h squared plus k. All right. So they give us the vertex. So this is our h and our k, and a point on the graph. So this is going to be our x and our y. Okay. So let me see. They didn't give us any information on a, so I'm just going to bring that down. X minus h squared plus k equals y. Okay. So I replace each component with a blank set of parentheses. X is -4. H is -3. K is 4. And y is 7. Notice at this point we have one equation, one unknown. There's only one thing we don't know, so we can solve the equation for the missing item. Notice we have that double negative at play. So double negative becomes positive there. -4 plus 3 is -1. Squared is +1. So then we're going to have a plus 4 equals 7. So then a equals, what is that, 3. Okay. Standard form. So then our claim is that it's going to take on the form 3x. Now our h is -3, so x minus -3 is really x plus 3. And our k is 4. Okay. So one thing to kind of note when it comes to the use of the h from the vertex is usually the opposite sign, because the formula is x minus h. So you just be aware of that, keeping track of that sign of h, and then k kind of follows your intuition. And it kind of coincides with like transformations where the inside is the reverse of our intuition and the outside follows our intuition. It kind of parallels that a bit. Okay. All right. I think this is okay. Okay. So here we're asked to sketch the graph. So notice that this one is already given to us in standard form. Okay. Let's identify our h, our k, and our a. So our vertex, which is our h comma k, remember that's supposed to be in the form of x minus h. So we really should rewrite that interior part as x minus a -2, right? And our k is 12. And then our leading coefficient is a -3, okay? So we have the coordinates of our vertex. We know that the parabola opens downward because of that negative leading coefficient. So then we also have our axis of symmetry. If the vertex is at -2, 12, that means we're focused on quadrants. What quadrant are we focused on? If the vertex is at -2, 12, then we're focused on quadrant 2. So I'm going to draw my graph. I'm just going to do a rough sketch, something like that. Move this up just some. About there is good. Okay. So we said -2, 12. All right. So then I'll go, let me style. One is good. Oh, then I did that before. Okay. Let me see. So we can go 2, 4, 6, 8, 10, 12, 14, 16. Again, this is my positive x in this direction, a positive y in this direction. 2, 4, 6, 8, 10, 12. We don't really need that many in this direction. And this one, I'm going by 1. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. So the reason I say that this is a rough sketch, because it's not necessarily drawn to scale. If I wanted it drawn to scale, I would use graph paper. So, when graphing, if you're doing a rough sketch, we increase our chances of making mistakes because, everything is kind of distorted, so it won't line up exactly. If we want to be more precise, we should use some graph paper. Let me see. So this is the origin. 2, 4, 6, 8, 10, 12, 14, 16. 6, 8, 10, 12, 14, 16. 3, 4, 5, 2, 4. Okay, so let's start with the vertex. All right, so -2, 12, that's going to put, and we got our axis of symmetry. So our axis of symmetry is going to be the x coordinate of the vertex. So that's going to be this guy about here. Style. We'll do that one. Colors. Let's go like this, like this. That's decent. And that's our axis, which was x equals -2. Okay. So we had a vertex of -2, 12. So that puts us right about here. And I'm going to label the point -2, 12. Okay. We had a negative leading coefficient, so that means the parabola opens downward. So now I'm just going to choose a few test points, all right? So for instance, when x is -1, -1 plus 2 is 1, squared is 1, times -3 is -3, plus 12 is 9. So another point is -1, 9, which is here. Okay. I'll label it -1, 9. I'll rearrange this just a little bit. Okay. And so when we went one to the right, we got a point. That means when we go one to the left, we also have a point. All right. So I'm just going to duplicate this. All right. So if we go left one, we're at this. We should be at 9 as well. Okay. Sketch the graph, right? And let's do when x is 0. When x is 0, 0 plus 2 is 2. Squared is 4. Times -3 is -12. Plus 12 is 0. Okay. Duplicate. So it passes through the origin. So if we go 2 to the right, we're at 0. So that means when we go 2 to the left, we should be at 0 as well. Okay. And then we just want to connect them with a smooth curve. So I'm going to do one more. When x is 1. 1 plus 2 is 3, squared is 9, times 3 is a -27, plus 12, let me see, 8 and 7, 14, 15. -15, okay, so it is on this chart. So -15 will put us right about here. Okay. So then if we connect the points with a smooth curve, I'm going to do something like this. We'll fix it. Give me just a moment. Okay, that's decent. Can I just put it directly on the point? That would be about here. And again, the reason the points aren't matching up exactly because it's not drawn to scale. So what I'm gonna do is just look like I got one. Yeah, that one. Okay, that's decent. Okay. So this was us drawing it by hand. Okay. I'd like to do a showcase with my TI-83 Plus. Let me see. Right here. Cool. All right. Go to refresh. Okay. So if I go to my y equals, I'm going to put -3 parentheses x plus 2 quantity squared plus 12. And I'm going to do a similar window to what we have. So I'll go to like -6. My x minimum, my x max, I'll go to like 3. X can go in steps of 1. My y minimum, we can go down to, let's go down to -20. And up to 16 is fine. And we'll go in steps of 2. And we should get a similar graph. Wait a minute. Window, y minimum, I think it's supposed to be a -20. Okay. All right, that's enough. Actually, I want to do one more in Desmos. So Desmos.com, open graphing calculator. And I'm just going to type the original f of x equals a -3 times x plus 2 squared plus 12. Okay. And again, there is a way we can we could adjust the window to match ours. I'm just going to kind of leave it as such. It just looks distorted because the window is different. If we change the window to match ours, it looks similar. Let me see if I can. Yeah, there we go. So all I'm doing is like a spread, the reverse of pinch. I'm working on a tablet, so that's how I was able to change it on the iPad. Okay. All right. Not too bad. Okay. So let's see the way that the textbook do it. Sketch the graph. Okay. They identified their leading coefficient and their vertex. Okay. Opens downward. I think it's the same thing. They found the x-intercepts, right? So I think you had to do a little bit of just solving, really, algebra. X and y intercepts, and that's fine. Got the same image. Those are reversed. Okay. Sketch the graph. Okay. So there's a couple of ways we can go about this. I'm going to just showcase one way that I want you guys to be aware of, but there are easier ways to go about this. But I do want to showcase this. And basically, I want to do a showcase on completing the square. That's one of those factoring techniques that we do expect you to already have some level of command on, but I personally acknowledge that students tend to have a hard time with it. So just do the best you can with it. Again, I'm just going to showcase completing the square, but then, there are other ways to go about this. So if we wanted to convert this equation into standard form, we would use completing the square, right? And so one of the first things with completing the square is that the leading coefficient has to be a 1. So in this case, what I'm going to do is factor out 2 from all the terms. Okay. So if I factor out 2, we're going to be left with x squared plus 4x minus 5. Okay. So then, oh, well, I guess we could just factor it. I don't think that'll help us. No. Let's do completing the square, right? So the completing the square step comes in the form. Now that we have the leading coefficient in the form of a 1, we're going to add 0 in the form of plus b over 2 squared and minus b over 2 squared. So we're adding something and we're moving that same thing back. And what this is going to do, this is going to allow us to change the form. It's not going to change the final answer because adding 0 is going to remain the same. This is going to allow us to change the form into something so that we can get it into the standard form, right? So our b in this case is going to be 4 at this stage. Okay. So the 2 comes down, the x squared comes down, and the 4x comes down. And we said b is 4, so we're really doing 4 over 2 squared plus 4 over 2 squared and minus 4 over 2 squared. Okay. And then minus 5. Okay. So then this is really x squared plus 4x. 4 divided by 2 is 2. Squared is 4, so that's really plus 4 minus 4. And then minus 5. Okay. So we have 4 or more terms. I'm going to use a technique called factor by grouping. I'm going to group the first 3 terms together and factor those, and then group the last 2. Okay. So let me see. The first 2. So, and keep in mind, we have to distribute this 2 as well. So just kind of be aware of that. Let's see. X plus 2 squared. That's a negative 9 times 2 is a negative 18. Okay, so now we have this one in standard form, right? So from here, we can see the vertex. So our h comma k. What does the x-axis to do? Graph. So the coordinates of our vertex. Remember, the formula is supposed to be x minus h. So instead, that's not really a 2. That's really a negative 2, comma negative 18. And our leading coefficient is a positive 2. So negative 2, negative 18 puts us in quadrant 3, and the parabola opens upward. So this is our positive x in this direction, positive y in this direction. We need to get down to like negative 20. Let me see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8. Let me see. 1, 2, 3, 4. 1, 2, 3, 4. Here's our origin. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. 2, 4, 6, 8. 1, 2, 3, 4. 1, 2, 3, 4. These are negative and negative. Okay. So let's see, the vertex is negative 2, negative 18. So our axis of symmetry, I'm going to start there. So this is x equals negative 2. Okay. Negative 2, negative 18 puts us like here. Okay. Let's see. When x is 0, right? Let's just go ahead and do that one. When x is 0, the corresponding y is -10. So we have this ordered pair 0, -10. So when we went 2 to the right, we were at -10. So that means when we go 2 to the left, we should also be at -10. Right about here. -4, -10. And then we just connect it with a smooth curve. That goes down to grid. Let's try that again. Let me see. When x is 2, 2 plus 2 is 4, squared is 16, times 2 is 32, minus 18. There's a 10 and a 4. It's 14. 214 goes off the chart. What about, let me see. What about when x is 1? 9 times 2 is 18, which should be a 0. Okay. So then 3, 1, 2, 3. Okay, this is about right. Again, it's just a little off because it's not drawn to scale. You know, that's the only reason like that 10 is not matching up. It's just because it's not drawn to scale. But that's okay. Let me see, I can kind of maybe collect that a little bit. Just a little bit. I don't know. I kind of really need to move that 10. That's the one that's off. But that's okay. All right. It's totally irking me, but I gotta let it go. Okay, and now, so this was a demo using completing a square. Another thing, or another technique that we could have used, we have another formula called the vertex formula. And so what this formula, let me see, it basically gives you the x coordinate of the vertex, all right? So the x coordinate of a vertex, which is our h, is going to be -b over 2a, okay? So from the original, if our b is 8 and our a is 2, then we would say -8 divided by 2 times 2, which is a 4. So -8 divided by 4 is -2. So then the x coordinate of our vertex, we could have just used that vertex formula and jump straight to the x coordinate of the vertex. Again, this is the vertex formula. And then once we have the x coordinate of the vertex, we just plug that value in to find the corresponding y coordinate. Okay. So we did a demo on completing a square, and let me do like this real quick. Okay. So, and again, if you're uncomfortable with completing a square, it's not a bad idea to like just do an internet search like on YouTube or Google and just watch a few videos on completing a square. Do the best you can with it. One workaround we have for this one is to use the vertex formula. And then once you have the coordinates of the vertex, which is the h and the k, then you can use the standard form of a quadratic and just plug in information that you have. Right? You can kind of work backwards. Let's see the way the book did it. Okay. So first they identified their A, B, and C, which is fine. Then they used the vertex formula, the -b over 2a. Okay. So then they calculated h. They got the same result we got, which was the -2. We took that result and plugged it back into the original, and then they got a corresponding y value of -18. Okay. So then they found the x-intercept. So they set y to 0, and they had to do some factoring, and they got -5 and 1, which I think we got. The y-intercepts at x is 0 is -10, so we found that as well. And then they use the axis of symmetry, right? So the x coordinate of the vertex is the axis of symmetry of the parabola. So again, whenever we get one point on one side, we automatically get another point on the other, the same distance away from the axis, right? And so you can see that applied here. And I think we essentially had those same points. Mhm. Okay. So the graph of this function is shown below. We're asked to find the domain and range of the function and then solve the inequality. Okay. So the domain in a graphical sense is going to be the very bottom to the very top. So if we're trying to find the domain of this image, we would ask ourselves, how far down does the graph go versus how far up does it go? So how far down, keep in mind the arrows just mean continue the pattern. It goes down to negative infinity and up. Sorry. Domain is the very left to the very right. So how far left does it go versus how far right does it go? Right. So domain, the very left would be negative infinity. The very right would be positive infinity. Right. If we continue those arrows, every x is accounted for. Another way to visualize domain, if we took this image and smushed it onto the x-axis, and then we ask ourselves, okay, what values of x is it touching? That's called a projection, that technique that we just described. Another way to kind of visualize that is like, imagine you had a light source, like one on top and one on bottom. It casts a shadow, and the shadow is going to cast a shadow onto the x-axis. So then that shadow, whatever x values that shadow will touch, is what we call the domain. Okay. So in this case, the domain would be all reals. So for part A, the domain from negative infinity to positive infinity. In this context, infinity always gets a parentheses. And then the range is the very bottom to the very top. I was getting ahead of myself before, right? So the range is the very bottom to the very top. So we're going to ask ourselves, how far down does the graph go versus how far up does it go? The very bottom will be negative infinity. The very top, it goes up to a y value of 3. Infinity in this context always gets a parentheses. And because we actually reach the 3, it's going to get a square bracket. Okay. And then solve. Okay, so they're basically asking, when is this quadratic positive? Or in other words, when is it above the x-axis? So whenever we were between those x-intercepts. Okay. So the left endpoint is going to be what? 4 minus the square root of 6 over 2. And the right endpoint is 4 plus the square root of 6 over 2. It's positive between these endpoints, not including the endpoints, so we'll use parentheses there. Yeah. Let me kind of check on you guys. I know we're almost at least done with the section. You guys look okay. Let's keep going. Okay, I think they got the same domain and range and the same solution for the inequality. Here we're asked to find the dimensions of a rectangular garden of maximum area. If the perimeter of the garden is 80 feet, what is the maximum area of each rectangle? Oh, here it is. So we're working with a rectangular garden, so it might be a good idea to start with a rectangle. Something like that. Okay, we're going to be comparing what the width to the length. We want to maximize the area. It says the perimeter is 80 feet. So when you see one tick mark like that, in this context, it just means feet. Double tick mark would mean inches. Okay. So then perimeter of an image like this, perimeter is just the distance around the outside. So if we add up the distance around the outside, we're going to have 2w plus 2l equal to 80. Okay. Let's solve for the length in terms of the width. So let's just solve for L. Okay. So then we get 2L equals 80 minus 2W. Divide both sides by 2. 40 minus W. Okay. So then an expression for the area is going to be length times the width, which is going to be the 40 minus W times W. So then that's going to be 40W minus W squared. Okay. Notice that the highest power here is Again, our goal is to maximize the area. The highest power on any variable is a 2. So that means this shape should be a quadratic, a parabola, a U-shaped curve. So the max should occur at the vertex, and notice that the leading coefficient is negative, right? We didn't put this in. We should probably put this in descending power order so we can be more clear. We can more readily see that the leading coefficient is negative. Let me kind of generate just a little bit of space. So again, our goal is to maximize the area. If we put it in descending power order, now we can clearly see that the leading coefficient is negative, which means our parabola opens downward, which means we have a maximum value there, right? So then we just want to find the coordinates of the vertex, okay? So we can use the vertex formula. Our h is going to be negative b over 2a. So in this context, it's going to be a negative 40 over 2 times negative 1. Looks like that's 20 feet. So when the width is 20 feet, that should maximize the area, okay? So then our claim is that the max area occurs when our width is 20 feet. Our length, let me see. We said that the length was 40 minus w. So 40 minus 20 is 20. And so the maximum area is going to be, plug in 20. Let me see, 40, 20, 400. Let's plug it in there. 20 times 20, so 400 square feet. Okay, so these are the results that we got. Okay. So kind of just seeing what the way the textbook did it, the perimeter, they said 2x plus 2l. They said x was the width and y was the length, which is fine. They did theirs in terms of x and y. We did w and l. Okay. So then they solved for the length of 40 minus x. I think we got divided by 2. Yeah, we got the same thing. So then the area in terms of x, we got the same thing, negative x squared. Ours was negative w squared plus 40w. Is a parabola with a vertex, so they solve for the h and their k. So the maximum area k of this rectangle is 400 square feet, which is 20 feet by 20 feet, and it's a square. Okay. Are there any burning questions before we go our separate ways? Let me share. Fall, traditional, this one, notes, updated daily. This should be correct. Okay. All right, so when this little window closes out, you'll receive a copy of anything that you saw me writing. If there aren't any burning questions, we're going to go ahead and end the session here. And on Wednesday, we'll do as much of the corresponding homework together as we can. All right, and from one beautiful mind to another, take care, gentlemen, and I'll see you next time. Peace. And I'm just going to stay on the call. I have another class in like 20 minutes. I just usually do one long stream for the 2 of you all. So I'll stay on the call if anybody needs me. So we set a timer for 2 minutes.
2 minutes starting now.
Siri, stop. All right. Check something real quick. Testing, testing. Okay. All right, gentlemen, welcome. I hope everyone had a great weekend. Let me see. I want to say that exam 2 was due maybe a few minutes ago. I think that's how it goes. So you can expect your grades to be updated within a week or so. Just be sure that you're making your way through the lab. Okay. Yeah, other than that, we're going to go ahead and move into chapter 2. So we officially finished chapter 1. Use this. So we're moving in, starting with chapter 2 with section 2.1, quadratic functions. A few objectives. 1, graph a quadratic function in standard form. 2, graph any quadratic function. 3, solve problems modeled by quadratic functions. So a quadratic function, a function of this form, f of x equals ax squared plus bx plus c. Yes. A, b, and c are real numbers with a not equal to 0 is called a quadratic function. Guess you guys are okay. One thing to note here is that the highest power in any variable is a 2, right? So the highest power is squared. We've kind of worked with this one in some fashion, form or fashion. This is going to make a U-shaped curve, okay? So then we want to take a look at what do we mean by the standard form of a quadratic function. The quadratic function f of x equals a times x minus h quantity squared plus k, where a is not equal to 0, we say that this is in standard form. The graph of f is a parabola with the vertex h comma k. The parabola is symmetric with respect to the line x equals h. It's called the axis of the parabola. If a is positive, the parabola opens upward, and if a is negative, the parabola opens downward. All right, so right, so in this form, right, this is the standard form of a quadratic. In my opinion, this is like the easiest way to graph a quadratic. We can in this form we can quickly identify the vertex of the parabola. So that's going to be the point on the graph where the turning point. So where the graph either goes from decreasing to increasing or vice versa, and that's going to be identified by the order pair h comma k. Okay. And then if our leading coefficient a is positive, the parabola opens upward. If our leading coefficient a is negative, the parabola opens downward. Okay. So here we're asked to find the standard form of a quadratic function whose graph has a vertex of -3, 4 that passes through that given point. Okay. So if you have a formula sheet, again, this formula is a good idea to update your formula sheet with the standard form of a quadratic function. Okay. And we're going to use that here. A times x minus h quantity squared plus k. Okay. So the vertex is going to be our h comma k. And this point on the graph is going to be our x and our y. Okay, if we plug those in, a we don't have any information on a just yet. X minus h squared plus k equals y. So our x is -4, our h is -3, our k is 7, and our y, sorry, I did that wrong. Our k is 4, and our y is 7. Okay. So at this point, we have one equation, one unknown, so we can solve. We have a double negative at play. So right here, this becomes -4 plus 3. So then -4 plus 3 is -1. Squared is +1. So now we have a plus 4 equals 7. And a equals 3. Okay. So then the standard the standard form of the quadratic, let's see, we're going to have a 3x minus our h. So it should be x minus -3, which simplifies to x plus 3. And our k is plus 4. Siri, turn the heater off. Okay. Okay, so here we're asked to sketch the graph of the quadratic. So we're fortunate because it's already in standard form. So let's identify the information that we get from the standard form. So the coordinates of our vertex are h comma k. So again, you have to keep in mind that the standard form is x minus h. So that's really an x minus a -2. So that should be a -2, and our k is 12. Our a, which is our leading coefficient, is -3. So the parabola opens downward. So we have the coordinates of our vertex. So -2, 12, that puts us in what? Quadrant 2. And that opens downward. I'm thinking something about like here. This will be our positive x direction. This will be our positive y direction. Let me see. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. This is this is a rough sketch. It's not necessarily drawn to scale. 3, 4, 5. 1, 2, 3, 4, 5. So the origin's about here. It's 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. One, 2, 3, 4, 5. Okay. So if we were to graph our vertex, which is negative 2, 12, let me actually start with the axis of symmetry. So the axis of symmetry of the parabola is going to be the x coordinate of our vertex. Again, this is x equals negative 2. So then we have a point at negative 2, negative 2, 12 is here. Okay. And then we can use the axis of symmetry to generate several points. Whenever we get a point on one side, we automatically get a point on the other. So for instance, when x is negative 1, negative 1 plus 2 is 1, squared is 1, times negative 3 is negative 3, plus 12 is 9. So when x is negative 1, the corresponding y is 9. Okay. So then that's the ordered pair, negative 1, 9. Okay. And then, so since we got a point on the right, we also get a point on the left. So if we go 1 to the left, we should be at 9 as well. Okay. And then let's go ahead and find some intercepts as well. For instance, when x is 0, plus 2 is 2, squared is 4, times negative 3 is negative 12, plus 12 is 0. So it passes through the origin. So if we go 2 to the right, we're at 0. Then that means when we go 2 to the left, we should be at 0 as well. Again, it's not drawn on the scale, so that's why it's a little bit distorted. We'll just go with it for now. Negative 4, 0. That's a sticker. I didn't even know I could do that. And then we'll do our best to connect it with a smooth curve. Again, it will be distorted just because it's not drawn on the scale. Let's see, I'll put that about there. When x is 1, 3 squared is 9 times 3 is what? Negative 27. 8 and 7, negative 15. So negative 15 puts it about here. Comes about there. That's not too bad. Again, it's just distorted because it's not drawn on the scale. If we wanted to be more precise, we would use like graph paper. No, I got one thing working, another one messed up. There we go. That's decent. We do kind of have a little bit of extra partial. I'll get rid of like this, like that. Nope. So this was us doing it by hand. Let me do a demonstration in the TI-83 plus. Is that the one I did for Desmos? -3 times x plus 2 squared plus 12, right? So here it is in Desmos. You know, just go to desmos.com and pretty much typed it in the way we saw it. We did have to distort the window to try to match ours a little bit. But yeah. And then just, yeah, let me just do a demo real quick in the TI-83 plus. Looks like we have it there. Oh, I think I just erased it. So -3 parentheses x plus 2 quantity squared plus 12. Window, hang on. So the x minimum, I'm going to go to like -6. And I'll go up to maybe 3. I'll go in steps of 1 on the x-axis. The y minimum, I'll go down to like -20 and up to about 16. I'll go in steps of 2. And so we should get an image similar to what we drew by hand. Okay. All right, let's keep going. Okay, so they identified their leading coefficient and their vertex, right? I think the same thing that we did. They plotted the vertex. They found their intercept, so x-intercept, y-intercept, and they got a similar image to what we have. Okay. So this one actually is a sketch the graph, right? This is a quadratic. Notice that it's not in standard form. So there's a couple of ways that we can go about this. I'd like to do a demonstration on how one way that we have for converting a quadratic equation into standard form. And so what I'm going to do is do a demonstration on, we're going to use the technique of completing the square. Completing the square is one of those factoring techniques that we expect you to have some level of familiarity with it. That's the best I'm going to get with that word. I usually struggle with that word. So that's one of those concepts that we expect you to know. I do have a handout in Blackboard. It's actually in Box. So you go to Blackboard, you click on, I think it's like the second link that says Box, daily lecture notes box link or something like that. And then there you're going to find a folder that says handouts. And in the handouts folder, you're going to find 2 documents devoted to factoring. One is a summary of all the factoring scenarios that we'll come across. And then the other is a digital copy of a chapter devoted to factoring. So it'll basically review all the different factoring scenarios that we'll come across in this course, including completing the square. So it'll have practice on completing the square. It wouldn't hurt to watch a video or two or just do a little bit of research on completing the square. If you're not comfortable with completing the square, it's okay. You can actually do most of the stuff without it, but if you know it, it helps. If it's too much, put it to the side, and you just have to work to try to find other ways around things, right? So one of the first things with completing the square is that the leading coefficient needs to be a 1, okay? And so I'm going to capture that by factoring out 2. So if we factor out 2, that's going to leave us with x squared plus 4x minus 10. Nope, minus 5, right? And so the completing the square, let me see. So again, we're doing a showcase on completing the square. I'm just going to abbreviate it as like this. Completing the square, and that's going to be here where we're going to add 0 in the form of plus b over 2 squared and minus b over 2 squared, right? So that's the completeness square step. We're adding 0, which is not going to change the final answer. It's just going to change the form of our equation into something that we can use. Okay. So that the 2 comes down, this first term comes down, the second term comes down. And our b in this case is 4. So we're saying 4 over 2 squared minus 4 over 2 squared. And then the minus 5. Okay, if we keep going, 4 divided by 2 is 2, squared is 4. So we're really saying plus 4 minus 4. And then minus 5. Okay. So now we have 4 or more terms. I'm going to use a technique called factor by grouping. I'm going to group the first 3 terms together and factor them, and then group the last terms, right? So the first, and it also kind of be aware that we're essentially distributing this 2 across, so we got to be aware of that as well. So the first 3 terms, they factor into x plus 2 squared. Negative 4 minus 5 is negative 9 times 2 is negative 18. So through completing the square, we were able to generate the standard form of the quadratic. So then from here, we can see that the coordinates of our vertex, so our h comma k, is going to be negative 2 comma negative 18. And our leading coefficient is a positive 2. So negative 2, negative 18 puts us in quadrant 3. The parabola opens upward. Okay. So we'll let this be our positive x direction. We'll let that be our positive y direction. Okay. Let me see. The vertex we said was negative 2, negative 18. See, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, it's not drawing a scale, so that's going to throw things off a little bit. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So if the coordinates of a vertex is negative 2, negative 18, that can serve as our axis of symmetry. So negative 2. Welcome. This is going to be x equals negative 2. Okay. So, and our vertex is negative 2, negative 18. So that's going to be here. The leading coefficient is positive, so our parabola opens upward. So then we can use the axis of symmetry to generate several points. Let's see what happens when x is 0. When x is 0, the corresponding y is negative 10 from the original. So we got 0, negative 10. So when we went 2 to the right, we were at negative 10. So when we go 2 to the left, we should also be at negative 10. And that's negative 4, negative 10, okay. If we wanted to find the x-intercept, we would set y equal to 0. If I use my standard form here, if we set that guy equal to 0, add 18 divided by 2 is going to be a 9. Square root of 9 is going to be plus or minus 3. So then it's negative 2 plus or minus 3. So then that's going to give us negative 5 and a positive 1. All right, so we have the order pair negative 5 comma 0 and the order pair 1 comma 0. Okay, so we have several points. So then we're just going to connect these with a smooth curve. Let me see when x is 2. 2 plus 2 is 4. Squared is 16 times 2 is 32. Minus 18 is what, 14? So 14 kind of goes off the chart. Okay. That was my best hand drawing to date. That's about right. It looks pretty good. I'm going to go with it. All right. Okay. Oh, so we were able to graph this using completing a square, and I made a disclaimer when we introduced completing a square. Again, this is just factoring, something that we do expect you to have some level of command coming into the course. So one other way we could have gone about this is using this formula called the vertex formula. I usually do my formulas in green. So again, the vertex formula for quadratics. So the x-coordinate of the vertex, which is our h, we can find that by doing negative b over 2a. Okay, so we could have jumped straight to the x-coordinate of the vertex. Our b would have been 8, and our a is 2, so it would have been negative 8 over 4, which is negative 2. So you see we have that same point for the vertex. So then once we have the x-coordinate of the vertex, we plug it into the original to find the corresponding y. So using that vertex formula, we can quickly identify our vertex, our h comma k. Our leading coefficient a is already given. Then we could just plug in the h, the k, and the a into the standard form of the quadratic. So again, we found the standard by using completing a square. We could have used the vertex formula to find h, plug it in to find k, and a was given. And then once we have that information, we could just plug it into the standard form of the equation of a quadratic, and we should get the same thing, right? So we have at least 2 different ways of drawing these similar conclusions. You have to forgive me. I am getting over a cold. And it's weird. I was going to be like, I thought my energy would be lower, but my energy is actually higher. I guess my body is like revving up, trying to fight it as best it can. But yeah, my voice is like, struggling here, but it's okay. Whenever my voice gets like this, I always think of like Phoebe from Friends. They're like, oh no, this is my sexy voice. Smelly cat, what are they feeding you? Smelly cat, it's not your fault, right? So, oh man. And then like there are these like weird conspiracies about that show. I know when I watched it, I felt like a lot of those jokes came straight from Seinfeld, like a verbatim. Like a lot of the stuff, I was like, yo, they did this exact same thing in Seinfeld. But somebody else was saying that, a friend of mine, she was saying that they pulled a lot of that stuff from Living Single. And she was like, that show was part of the reason why Living Single went off the air. And then there was a conspiracy about Phoebe, like even though she was ditzy, she was actually like a genius and all this other stuff and some kind of spy. It was like all this weird stuff. I was like, oh, okay. So anywho, me and my sexy voice, all right. But yeah, so and then I got another class this evening. I'm like, man. So I'm just trying to like save up my energy. But I got my little tower. My tower gives me energy because I'm just standing. So that helps. That helps a lot. Okay. So I think we're good here, right? So again, we did complete in the square, and we also kind of mentioned the vertex formula. Okay, I'm glad that that's there. That's critical. In my opinion, I think the vertex formula is a lot easier to process than completing the square. It doesn't hurt to have both of those at your disposal. Sometimes one is easier over the other. Yeah. And I think we got the same image. Okay. So we're moving and grooving. We might finish a little bit early. I've actually low-key been stalling a little bit. But I mean, we're pretty much where I was with my earlier groups. So we're just going to kind of keep going with it. It says the graph of this function is shown below. We're asked to find the domain and range of the function and then solve the inequality. So in a graphical sense, the domain is the very left to the very right. So if we took this image and smushed it onto the x-axis, how far left would it go? How far right would it go? So the very left to very right in this context. So for A, come on. The domain is going to be negative infinity to infinity. The range, so if the domain is the very left to the very right, the range is the very bottom to the very top. So how far down does this graph go? It goes down to negative infinity. How far up does it go? The highest y value looks like it's a 3. In this context, infinity always gets a parentheses. 3, because we actually reach 3, it's going to get a square bracket. And then when it asks to solve the inequality, it's basically saying, when is this parabola positive? In other words, when is it above the x-axis? So looking at the graph, it's above the x-axis between those two x-intercepts. So it's going to be positive between those guys, right? So the left endpoint is going to be this 4 minus square root of 6 over 2. And the right endpoint is going to be 4 plus the square root of 6 over 2, okay? And it's positive within these bounds, but not at the bounds. It's equal to 0 at the bounds. So that's why we're using parentheses over square bracket. Because we want to know when is it strictly larger than 0. Okay. Suppose we didn't, the x-intercepts weren't given. This is where you have one of two options. Either use completing the square to write the quadratic in standard form. And this is going to be a little bit challenging because all the terms are not divisible by 2. Or we could use the quadratic formula. Quadratic formula. So the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks and it was all over by 2 a.m. That whole thing. We can use that to generate these x-intercepts as well. Okay. But since we were given this graph, I just went with it. Okay. Oof. I hope everyone is beautiful. Man, that was like an oasis. I hope everyone is doing well. I know this is like a while ago. I'm just, for whatever reason, that whole image of the chemical explosion we had here in the city. You know, I saw something in my YouTube feed. I didn't watch the video, but you know, the thumbnail and the title said, you know, residents coughing up blood after the chemical explosion. I was like, all right, here we go. You know, and it's just like, as much chaos as there is going on, I'm not gonna lie, it is kind of exciting to be alive. Like, there's all this buzz about, you know, Sumerian gods returning. We got all this chaos going on in the form of, you know, we got flooding. We had like snow and winter stuff going on in the middle of summer in Mexico and Texas and places like that. Just random weird stuff. It was like, what is really going on? So, you know, it's unfortunate that, like, you know, everybody's like suffering and in turmoil and stuff like that. But it just leads to this, like, okay, something big is like on the precipice or whatever. And obviously it could be chaotic, but it could be something beneficial as well. You don't know. It's like something good could be coming, and this is like the powers that be trying to, you know, their last grab for power. It's like, okay, well, if I can't have it, nobody can. That's the vibe that I get. It's like, it's kind of like a flicker of a candle right before it goes out, energetically, right? You know, the candle's about to go out, it does a wild dance and it extinguishes. I just sort of energetically I feel what's going on, like with our leaders. They know they're losing power and they're about to be dethroned and be revealed, and you know, they know that the power is about to be taken from them. So they're creating all this chaos through like HARP and weather manipulation, you know, stuff like that. So it's just interesting to me. You know, the chemtrails and everything. But I usually kind of check for the chemtrails when I go outside. I haven't really seen them. It seems like they died down a lot lately, but I also haven't been outside as much as I usually would like to be. But anywho, okay. Okay, I think we got all of this stuff. Okay, so give me a moment. All right, so here we asked to find the dimensions of a rectangular garden of maximum area. If the perimeter of the garden is 80 feet, what is the maximum area of each rectangle? Okay. All right. So let's start with the rectangle. So we have a rectangular garden. And let's say that this is the length. Let's say this is the width. It says the perimeter of the garden is 80. So perimeter is a distance around the outside, right? So we have two L's and two W's. So then we can say 2W plus, let's change the color. 2L plus 2W equals 80. And again, our goal is to maximize the area. The formula for area is length times width, okay? So we can solve for the length from the perimeter, and then we can write the area in terms of one of the variables. Okay, so if we solve for L from the perimeter, let me see, we're going to have 2L equals 80 minus 2W. Divide both sides by 2. Oh my goodness. I think he's like asking the wrong person. He's asking me things that's out of my control. So we divide both sides by 2. 40 minus W, right? So now we have the length in terms of the width. So then again, our goal is to maximize the area, but the area is the length times the width. So that's going to be 40 minus W times W, okay? So then we can distribute this W. And I'm going to put it in descending power order. So we have a negative W squared plus 40W. And again, our goal is to maximize the area. Okay. So now we have the area in terms of W. Notice that this formula, the highest power is a 2. So it's a quadratic. It's a U-shaped curve. The leading coefficient is negative, right? I intentionally put it in descending power order so that it's easier to identify our leading coefficient, which is -1. The leading coefficient is going to be the number in front of the term with the highest power, right? If we had left the 40 in front, the squared still would have been the leading term, right? So the leading coefficient still would have been -1, but it would have been a lot more challenging to realize it if we didn't put it in descending power order, okay? So then, so we should have a U-shaped curve that's opening downward. So that means we should have a maximum value, and that should occur at the vertex. So we're going to use our vertex formula. Negative b over 2a. So our b in this case is the 40, so that's going to be a negative 40 over 2 times -1. So that looks like it's 20 feet. And that's a width, right? So our claim is that the area is going to be maximized when our width is 20. So if our width is 20 feet, all right, that means our length is also going to be, let me see, 40 minus 20 is 20 feet. And the maximum area should be 400 feet squared. Okay. Are there any burning questions before we go our separate ways? Let me let me make a copy of this available. Share. Traditional. One notes. Updated daily. Okay. So when this little window closes out, you'll receive a copy of anything that you saw me writing. Let me see. If there aren't any burning questions, we're actually going to go ahead and end the session here. And on Wednesday, we'll go through as many of the corresponding homework questions together as we can. With that, we're going to end the session here. And from one beautiful mind to another, enjoy your evening. And I'll see you on Wednesday, same time, same place. Take care. Peace. I don't see any questions. All right, guys, take care.